Let's now take a look at a model called the variance-gamma model. The variance-gamma model is basically just a conditional normal distribution model, where the condition is based on a particular variable called g, and this variable is actually drawn out of a gamma distribution. Therefore, the name variance-gamma model. So essentially, you will have to draw out of a gamma distribution to get a G number, and depending on the G number, they will determine that the mean and the variance of a normal distribution. Now, in this case, if we implement that for a stock market, you will typically get a conditional distribution. This conditional normal distribution will apply to the log s rather than the value of s itself, so that you would not have negative stock prices. The variance gamma model is it's a model where you can apply it to both the equity market and the currency market, because you can produce a fat tail for one side or on both sides, depending on a parameter we call theta that we will see a little later. The theta is out of the gamma distribution. Now, so if you have a number g that is joined, the conditional mean will take this particular form. Okay, so it's the log of the initial s, right, with the current observed log price, and then this part is this typical r minus g time, and it will plus an omega and plus theta g here. Now, the conditional standard deviation would be sigma times square root of g. Now g is taken out of a theta, out of a gamma distribution from here. Then you will see that this theta value here, or theta parameter, is very important. You typically would, depending on whether you're dealing with the equity market or a currency market, you would determine you'll put some restriction on the parameter theta. So if theta is equal to 0, we will have a symmetric shape. Okay, so then we'll have both the left-hand side and the right-hand side will be a little thicker, or we call that fat tails on both ends. Then this, if you're dealing with a currency market, you want to force this to be 0. And if you are working with the equity market, instead of forcing this to be 0 as for the currency market, you would have forced this to be negative for the equity market. Then if theta is negative, you'll get a negative skewed distribution there, which is typically observed in the equity market. You will typically not allow theta to be greater than 0, because that is not really typically observed in any of the market that we have seen. So by forcing theta to be taking particular ranges of value, then you can basically generate your variance gamma. You get your gamma distribution, and then out of that, you will get your conditional normal distribution, and you basically then, for each of the g you draw, then you draw the mean, and then you can draw your changes from the conditional normal distribution. Now, unfortunately, for variance-gamma model, there isn't a closed-form solution that you can utilize for simple options. Therefore, it makes the parameter calibration a little more difficult. Under the variance-gamma model, the way to implement is that you will first determine this, crucial variable g. You basically have to join out of a gamma distribution. So you first join out of a random number out of a uniform distribution from 0 to 1. And so and once you have obtained this realized R on the uniform distribution, then like any other ones, you use the cumulative inverse cumulative gamma distribution to get your G there. And so you have to, you get that by looking at the right T, which is time to maturity, and you need this variance of the gamma distribution. And once you have that, you this will give you the standard deviation, the conditional standard deviation that you have on the conditional normal there. And then you will also be able to determine the conditional mean based on this one here. Okay, now you have your mean and your standard deviation for the normal distribution, and then out of that normal distribution, you can draw random numbers, and that random numbers will give you the change of value, the random change of value. So then you repeat this again and again. So every time you have to first determine the G in this process here. And then when you have the G, you then again have another conditional normal distribution and with a different mean and a different variance. And then that's where you draw for another random change. Okay, so essentially, every step of the time, you're drawing out of a different normal distribution. They're all normal distribution, but each of them has a different mean and a different variance. And the mean and the variance depends on the random draws of the realized G. And then you can do your simulation based on that process. And as mentioned earlier, you can apply this, although this is complicated, but you can apply this by on both the currency market, on the stock market, by assuming different values of theta. Theta is 0, you apply this to the currency market. If theta is less than 0, you will then apply this to the equity market.